To complete the power plant builder portion of our prediction, we'll begin by clicking Start on the Blocks and Arrays attribute section. So this section's designed to work dynamically, providing the user a quick means to scale up or down a particular block type with any combination of subsystem components. So mounting orientation, module type, inverter type, etc. These components are organized using tabs. So working left to right, you can see we have block, we can add an array, and then later on you'll see to add inverters and DC fields. So if we look at the block tab, it's pretty basic. We have a toggle to turn on construction dates. So if you wanted to enter an energization date, you can do so here. You can add an array by clicking Add. Now we want to define how many of this array type. So let's say 10. Array type 1. And then we can enter the high side voltage that's anticipated. And you'll see here we have some default values loaded for the average user. You can, of course, override these by just clicking in the field and typing your value. Same for electrical losses. We have some default values in there. And this kVA rating will update once you add an inverter. So let's go ahead and do that. We'll click Add Inverter. So here we have the inverter library displayed, and you can search the vast library of inverters. So for this, we'll choose GE, Pro Solar 4 megawatt. We'll click this inverter. So now you can see that I have this inverter selected. We can enter a desired DC-AC ratio. So I'll do that here. And same with this real power set point. And you can see the power factor will update automatically for you. So now that we have our inverter selected and set point defined, we can put a DC field behind it. So click Add next to the DC field tab. This displays the module library, so we can make our module selection. Select this module. So now you can see we have a module selected, some default values pre-populated for you in the electrical characteristics. I'm going to change this to 15. Nameplate power is based off your desired DC-AC ratio that was previously entered, and then these parallel strings and module counts are calculated based off that. For losses, we have some default values pre-populated. You can change that if so desired. Light-induced degradation, if applicable. DC wiring at STC. For our advanced users, you can click this drop down here with even more parameters to define. Heat balance coefficient, Sandia coefficient, cell to module temp differences, so on and so forth. For now, I'm going to leave these as they are. Now let's move to the mounting structure. We have fixed tilt and tracker. One thing to point out with the fixed tilt is we do have a seasonal tilt toggle here, so you can define custom angles for a given month. For this demo, let's go to tracker. We'll enter the rotation of 45 and 45. PlantPredict supports two different tracking algorithms, true tracking and backtracking. Because I've selected a First Solar module, I'm going to leave true tracking selected. You can define the orientation of your module here, portrait, landscape, azimuth, number of modules high in your mechanical table, and then this collector bandwidth will populate automatically based on the module selection. You can enter a desired GCR or row spacing. In this case, I'm going to put in 6.7 meters. And you can see our nice illustration here is updated with all these entries as made. And again, for advanced users, you can click Show Advanced Settings. You can further define module parameters. You can define the width of your mechanical table, number of rows in your field, so on and so forth. So now I'm going to move back up to the top. You can see everything's populated. So the beauty with PlantPredict is the scalability. So let's say we wanted to add an additional block here with much of the same parameters, but maybe a different inverter or slightly different characteristics of the DC field. We can clone block 1, so we'll click clone. You can see the numbering's updated, indicate we're now on the block 2 parameters. So let's say we have 15 of this array type, and we'll call the array type 2. Leave these the same. Let's move to inverter. Maybe it's a slightly higher DC-AC ratio. Same set point. Can move to the DC field. Maybe we want to change the selected module. So we'll go with this module here. Update that. And it's the same. True tracking. And let's change the row spacing to 5.7 meters. And maybe longer rows, so there's fewer of them. All right, that looks good. So we can save progress, and you can click Save Progress at any spot. Doesn't matter what tab you're on or what you're working on. It'll save the state of it of the builder. So now you can see we have 2 blocks. There's also an exploded view that you can enter, which makes navigation really quick. So if we wanted to go down to this DC field, I can view that asset, and it takes you right there. So now that we have 2 blocks, I think that's pretty good. So we can click Save and Close Power Plant, and we can enter the System Attribute section, where we can define a plant output limit. So again, there's a nice drop down here for reference. So we have a 100 megawatt plant. Maybe the output limit's at 95. And then to add any transformers or transmission lines, you click this add icon. Let's add a transformer. We'll leave the MVA rating alone. Let's say 115 kV. And again, there's some default values here loaded for an average user. You can, of course, overwrite these if desired. And we'll do the same for a transmission line. Let's say 5 kilometers. And again, resistivity values are in there for you by default. So that looks pretty good. I'm going to go ahead and save and close Power Plant. Now we're back to the familiar prediction dashboard, where we continue on to entering simulation settings.